AI can pass the bar exam and generate photorealistic art in seconds. Yet despite that massive computing power, the technology cannot yet perform the act of original invention. Large language models, or LLMs, operate as advanced statistical engines. An LLM is a type of artificial intelligence designed to generate text by predicting the next word based on patterns found in massive datasets. These systems string together concepts based on mathematical probabilities, matching existing human patterns rather than engaging in independent thought. These models excel at interpolation. They fill in the blanks within the boundaries of frameworks humans have already built. They cannot extrapolate, which requires stepping outside those established boundaries to generate a scientific law that has never been recorded. If you ask an AI to explain gravity, it will recite the textbook definition of force equaling mass times acceleration. But if you provided only raw data of falling objects and planetary orbits, the system lacks the internal architecture to independently deduce that equation. This creates the black box problem. The black box problem refers to the inability of human operators to see or understand the internal decision-making processes of a complex AI. When current systems reach a conclusion, they do so through billions of hidden mathematical weights, not through explicit traceable logic. A system that only regurgitates existing human knowledge functions as a powerful oracle. Until a machine can autonomously observe data, invent a novel concept, and formally define it, we have not reached artificial general intelligence. Artificial General Intelligence, or AGI, is a theoretical form of AI that possesses the ability to understand, learn, and apply knowledge across a wide range of tasks at or above human-level capability. Before the late 17th century, physics consisted of fragmented observations. Astronomers tracked localized data points, like the trajectory of a comet or the phases of a moon, but they lacked a single mathematical framework to connect them. Isaac Newton took thousands of those disconnected observations and compressed them. He created formal definitions for mass and force, building universal equations that explained both a falling apple and an orbiting planet. Independent researcher Keith DeCesare has proposed a theoretical architecture that mirrors this historical leap to address the limitations of modern AI. It is known as the DeCesare protocol. This protocol introduces an architectural layer that functions as a digital quill. This layer enables the machine to generate its own explicit definitions for the phenomena it observes, rather than relying on statistical correlations. Achieving this capability requires a structural addition to the AI's core design. Simply increasing the volume of data ingestion within existing models will not produce this type of conceptual reasoning. The architecture starts with standard neural networks. Neural networks are computing systems modeled on the human brain that identify patterns from input data. Here, raw sensory information flows into a grid, allowing the system to detect continuous, fuzzy patterns. Next is the clustering layer. The system applies algorithms to crystallize those fuzzy patterns into discrete tokens of meaning, creating the raw material for conceptual invention. The innovation lies in the definition builder agent. This component observes those tokens and locks them into an internal dictionary, assigning formal, explicit definitions to the new concepts the system has identified. Above that sits the symbolic reasoning layer. A symbolic reasoning engine is an AI system that solves problems by manipulating explicit symbols and logical rules, rather than relying solely on probabilities. It translates these new definitions into testable mathematical models. Finally, the metacognitive layer evaluates the work. It runs simulations to test these machine-generated theories against real-world data and loops the equations back for revision if they fail to predict reality accurately. This 5-layer sequence effectively automates the scientific method. The machine can now observe, define, theorize, test, and refine its understanding of the world. By shifting from a statistical autocomplete engine to this layered architecture, an AI begins operating like an autonomous research institute. Because the system builds an explicit conceptual dictionary, the internal reasoning becomes transparent. The machine no longer hides its conclusions inside a mathematical black box. It produces a visible network of concepts and relationships. If an AGI discovers a medical treatment or a military strategy, human operators can audit the exact definitions the system created to verify the safety and logic of its discovery. Scientific progress has always relied on the ability to codify data into laws. The next leap in technology requires moving away from mere data ingestion and giving the machine the tools to formalize reality. Artificial general intelligence finally arrives when the machine possesses the agency to formulate its own scientific principles. By handing the machine its own quill, we enable it to independently define the rules of its environment.